Welcome back to the flipped classroom. Our topic today is more log equations, believe it or not. So we're going to practice some log equations, but our main goal is to focus on the domain of these log equations. All right, so we're going to run through some examples on just stating the domain strictly. So question 1, log base 3 of x. So we said, and you can verify this by looking at the graph, whatever we're taking the log of cannot be negative or 0. And again, I will make a quick graph of log base 3. I should have a vertical asymptote at x equals 0, crossing through that point 1, 0, and it grows pretty darn slow. Okay, notice this should be getting close to the asymptote but not touching. So if I take a look at this, I can easily state graphically by looking at it that the x values have to be strictly greater than 0. Notice I'm not using equal to. I have to be greater than 0. Cannot be 0 and cannot be negative. So let's get that in our notebook one more time. Must be greater than 0. Not equal to 0 and not negative. So basically, I don't want to graph this function every time to state the domain. We want you to be able just to look at this equation and come up with the domain. So it's pretty straightforward. You're going to take whatever you're taking the log of and say it's greater than 0. So let me show you another example. Number 2. If I said log base 3 of x minus 6. Okay, so I want you to be able to state the domain without graphing it. Now you can check graphically, and if you really want on a multiple choice question to go ahead and graph it and state the domain, that's fine. But you should be able to take just whatever's in here and say to yourself, write it on paper, that the junk I'm taking the log of can't be 0 and it can't be negative, so it has to be greater than 0. And then just solve for x. Add the 6 over, so x has to be greater than 6. And that's your domain. Just what can the x values be? Have to be greater than 0 is the whole trick. So again, if you wanted to take the time to sketch this out, and your calculator would do it for you, you should be seeing an asymptote at 6, and then the graph kind of squeezing in like this. All right, but again, we're just going to take what's in there and say it has to be greater than 0. So with that in mind, let me throw another one at you. So without graphing, log base 7 of 4 minus x. All right, go ahead and find that domain. All right, so hopefully you've got it by now. You're taking whatever's in here and saying it has to be greater than 0. Solve for x. So two ways to do it. If you subtract the 4 over, you get negative x is greater than negative 4. And now you're going to divide by a negative, so be careful there. When you divide by a negative, make sure you flip the sign. So I should have x is less than 4. And again, feel free to check it graphically. Let me keep going. I'm going to throw just a couple at you. You try them on your own, then I'll fill the answers in a moment. All right, so there you have them. Copy these down. And again, pause me. You set up the problem to find the domain for each one, and then I'll have my answers up in a few seconds. All right, so you can run through mine and check. X minus 8 is greater than 0. Add the 8 over. Domain, x is bigger than 8. Add the 5, divide by 3, x should be greater than 5/3. Watch this last one here. If I subtract the 10, I have to divide by a negative, so make sure you flip the sign. So x is actually less than 10. Okay, hopefully you're feeling good about domain. So we're just going to practice a few more log equations, and we should have a pretty nice night tonight. All right, log base 8 of x plus log base 8 of x minus 6 equals log base 8 of 7. So that key word we talked about is to condense. All right, we're condensing these logs into one log. So that's log base 8. And when I say condense, you just have to watch the sign. Where did this plus come from? So remember that's law 1, which means it came from multiplication. So x and x minus 6 equals, now there's nothing to condense on the other side, so we're just rewriting it. Okay, now this is kind of the nice version. When there's logs on both sides, we just canceled them out because we said they had similar to like bases. So now I'm just going to distribute x squared minus 6x equals 7. Set it equal to 0, of course, before you factor and get your two values. I've got x equals 7 and x equals -1. Now don't forget that most important part to check your answers. Okay, we cannot take the log of a negative. Make sure you check, or 0. All right, let me give you another method to checking than kind of just plugging those two numbers in. Let's just state the domain of each of these log functions. So I'm basically just going to say this x value has to be greater than 0, and that this x minus 6 has to be greater than 0, so really x must be greater than 6. All right, so now I'm going to check my answers. Well, does 7 work here? Is 7 greater than 0? I would say true. Is 7 greater than 6? I would say true. So 7 checks. Let's do the same thing with -1. Is -1 greater than 0? Well, heck no, so that fails. I don't need to test it again. That one's done, so my only answer is 7. All right, but feel free to state the domains, and perhaps that'll help your check. All right, let's try another one. All right, question 8 here. Log base 7 of 3x minus log base 7 of x minus 2 equals 0. Now notice, every term doesn't have a log, so we're not going to kill them in the end. We're going to have to do some converting. But let's start back to basics here. Your goal is to condense this side into one log. So my log is log base 7, and watch that operation. Subtraction means these two terms came from division. So 3x over x minus 2 equals 0. Now again, what I was saying is I can't kill this log base 7 because there's nobody equivalent over here. So we did our condense method, and after we condense, if we can't kill, then we convert. Okay? Now, it should be pretty obvious what form you're converting to. If you see the word log, you're in log form, and you need to convert to exponential. So, start with your base. It's going to be 7 equals the exponent, so the exponent's always what your function's equal to. 3x over the x minus 2. Now be careful here, a lot of people end up putting a 0 there, but we should know anything to the 0 power is actually 1 equals the 3x over the x minus 2. I'm going to put this as 1 over 1 and treat it as a cross multiply. 1 times x minus 2 equals the 3x. Solve for x, so I get -2 equals 2x. Divide by 2, x equals -1. Now that doesn't mean it works. I've got to go back and check. All right, I've rewritten it and kind of squeezed it in here. And I'm going to use my domain method here of what I'm taking the log of. So I'm going to say my 3x has to be greater than 0. And if I solve, that means x has to be greater than 0. And in this case, my x minus 2 has to be greater than 0, so x has to be greater than 2. So now I'm just going to see if my solution here follows that rule. Is -1 greater than 0? Well, nope, it fails right there, so I'm automatically rejecting this. Now since I don't have another value to even test, I don't actually have any answers, so you can either have the empty bracket or you can write no solution if they both fail. Well, believe it or not, guys, this, I believe, is going to be the end of the video for tonight. So take your time with these log equations. We're going to practice them again tomorrow and really focus on that domain. Have a great night, and we'll see you tomorrow.